Hello everyone, welcome to the first day of chemistry instruction. Today we are going to start with matter, mass, and volume. So on your Edmodo page, you are going to scroll down until you find the assignment for 813 entitled Matter, Mass, and Volume. So in that post, you are going to find the link for the reading, and you are going to find the attached PDF. Once you open this and answer all the questions, be sure you send your answers to me via email at mbrinkman@acceleratedlearningscenteraz.com. So to get started, we are going to click the link for the reading. All right, and there we go. It's matter, mass, and volume. So let's start. So matter is going to be anything that exists in the universe that we can see and touch. So it's all the stuff that's in the universe. So the only thing that isn't going to be matter would be any form of energy. Light, heat, sound, that's not matter. The scientific definition of matter is anything that has mass and takes up space. So this one says anything that has mass and volume. Volume just means it takes up space. So matter is anything that has mass and takes up space. So let's get to our first property, which is mass. So mass is going to be a measure of the amount of matter that is in a substance or an object. We measure mass using the kilogram or the gram or any smaller or larger measurement using the gram in the metric system. So to measure mass, we use a balance. And actually, in the lab, in our modern times, we're going to use a digital balance. This down here is what you call a triple beam balance, where you adjust all these little things down here, but we're going to use digital balances. Okay, it's just a lot easier. So mass is the amount of stuff in an object. And we'll get to how mass compares to weight. So mass versus weight. This is kind of a confusing concept because we think of mass and weight as kind of the same thing. But mass is going to be the amount of stuff that you or any object is made of. With weight, we factor in the mass plus the force of gravity pulling that object down. So if we want to compare it, make it a little simpler, if you're on the Earth and you're on the moon, you are going to have the same mass in both locations. You're going to be made up of the same amount of stuff regardless of location. So weight, if you compare between the Earth and the moon has a much weaker gravitational field than the Earth. So your weight is going to be less on the moon than it is on the Earth. And finally, we get to volume. So volume is going to be the amount of space that a substance or object takes up. Now, there are two types of measurements that we use for volume. So we can use the cubic meter and any variation of meter, so centimeter, decimeter, and we can also use liters or milliliters. So cubic centimeters, cubic meters are usually used to describe the volume of solid objects. Liquids are usually measured in liters or milliliters. So how the volume of matter is measured is going to depend on the state that it's in. Is it solid, liquid, or gas? So I already went a little bit over how liquid and gas are measured as far as units, but when we're measuring liquid, we're going to use some type of container. We can use a measuring cup, we can use a graduated cylinder, we can use a beaker, just has to be a container. When we are measuring the volume of the gas, it is going to be the volume of its container because a gas is going to expand to fill all the available space. And then the volume of a regularly shaped solid, let's say a solid rectangle, it is going to be calculated from its dimensions. So you're probably familiar with the equation, length times width times height, and that's how you would get the volume of a rectangular solid. Now, if you're trying to measure the volume of something that has an irregular shape, you can use the displacement method. We'll be doing a lab involving the displacement method, but basically what you do is you have a container of water, you measure your starting volume, and then you place the object in that container and you measure your final volume. You do final volume minus initial volume, and that is going to be the volume of your irregular solid. So we are going to meet this morning, and that is when I'll give a little bit of a review of this stuff, and then you can also ask any questions.